I'm going to talk about digestion and make it very simple for you to understand. The goal of digestion is getting something very large, like a protein, and breaking it down to an amino acid. Getting something very large, like a carbohydrate, and breaking it down to something very small, like a monosaccharide. When we do that, we absorb the smallest things. Now, as I said, it's going to be simplified. So, could you absorb a dipeptide or a disaccharide? Yeah, sure you can, but if you kind of think about it as the smallest portions we absorb, easier to understand. So here we go. So the mouth is where we start digestion. Carbohydrates start breaking down in your mouth. A little bit of fats, but mostly carbohydrates, and then you swallow it. It goes down the esophagus, and the esophagus is only there to transport, and it goes all the way down to your stomach. And then in your stomach, it's going to start to stretch. It's going to distend. It's going to activate in your stomach the G cells. The G cells are going to secrete gastrin. Gastrin's a hormone that's going to kind of start the entire digestion process. Gastrin will stimulate the neck. They're called neck cells. They're also called mucus cells. They're also called cardiac cells. All kind of the same thing. They're going to secrete mucus. Mucus is going to protect your stomach lining for what's going to come next. Gastrin is going to also stimulate the chief cells to make pepsinogen. Look at that term, inogen. Inogen is what we call a zymogen. Zymogens are inactive enzymes. Tell you what's going to happen here in a minute. The mnemonic is Chief drinks Pepsi. Then the parietal cells, they're going to make hydrochloric acid. Hydrochloric acid is going to convert pepsinogen into pepsin, and then pepsin will start to digest proteins. Protein digestion starts in the stomach. People say, hey, hydrochloric acid digests things, but actually it doesn't. Hydrochloric acid activates the enzyme to digest proteins. Parietal cells will also make intrinsic factor, which we'll talk about that in the next slide, but intrinsic factor is going to absorb vitamin B12. So all this is happening in your stomach. Then what the contents becomes is this acidic paste called chyme. It's like a acidic baby food. This chyme is going to go down through the pylorus, through the pyloric sphincter, into the duodenum. Duodenum is the first part of the small intestines for digestion. The duodenum has what we call Brunner's cells, or Brunner's glands, and the Brunner's glands make an alkaline mucus to protect it from all of that acidic chyme to go into there. When it goes into the duodenum secretes a hormone called secretin. Secretin goes to the pancreas to release bicarbonate. Bicarbonate is a basic solution exocrine that's going to go into the duodenum. It's going to neutralize that acidic chyme. The duodenum also makes what we call cholecystokinin. That hormone is going to go do several things. It's going to go to the gallbladder to release bile. Bile will get released into the duodenum. Now, what bile is like an emulsifier. Oil and water doesn't mix. If you want to clean a dirty, oily pan, water can't just clean it. You need to put like Dawn detergent. That detergent is like bile. And what it does is it lowers the surface tension of fat, so then water can clean the pan. Well, bile does the same thing for fats. It emulsifies fats, lowers the surface tension, so the pancreas could actually digest it. Cholecystokinin also goes to the pyloric sphincter, closes the sphincter. Cholecystokinin also goes to the stomach to inhibit the G cells, to stop gastrin so the stomach starts slowing down. Cholecystokinin also goes to the pancreas to release its digestive enzymes. You got amylase. Amylase is going to digest carbs in the duodenum. Pancreas will also release lipase. Lipase will then go in the duodenum to digest fats, but remember we need bile to help with that. Pancreas will also release trypsinogen. There's that term again, inogen. Trypsinogen is going to be released, it's inactive, into the duodenum to be activated into trypsin. Enterokinase from the small intestines activates trypsinogen to trypsin, and trypsin will continue to digest proteins in the duodenum. Now, it's designed this way, just like the stomach. These cells have to make an inactive enzyme called the zymogen, because the stomach and the pancreas are made of protein. So if it made an active enzyme to digest proteins, it would digest itself. Be very painful. As a matter of fact, acute pancreatitis is when trypsinogen in the pancreas activates within the pancreas, and the pancreas does digest itself. So that's what's happening in the stomach and the duodenum. So as the contents continues down the small intestines from the jejunum to the ileum, they're going to break down into smaller and smaller components. Like a tripeptide will break down to a dipeptide will break down to an amino acid, and you absorb it in the ileum. Trisaccharide will break down to a disaccharide to a monosaccharide. You absorb the monosaccharides in the ileum. So everything is absorbed in the ileum. And now that's where the intrinsic factor I talked to you about from the parietal cells of the stomach is needed. The intrinsic factor is needed to absorb B12 in that distal ileum. Water, most of your water is absorbed in the ileum as well. So everything that passes through the small intestines, their nutrients are going to go through the ileocecal valve into the cecum. Once it reaches the cecum, not much absorbable in that area. It's pretty much fecal material. So it's going to go up the ascending colon, across the transverse, down the descending, through the sigmoid, and out the rectum. But what's happening during this pathway of the large intestine, you've got water absorption, but most of it's in the ileum, remember. The water absorption in the colon is only there to concentrate the fecal material. Inside of your large intestine, you have E. coli bacteria, colon. And what they do is they eat the fecal material that's in there. And when they eat the fecal material, they are releasing their waste products. They release B6, which we use for protein metabolism. They release B7, which we use for fat metabolism. They also release vitamin K, which we use for clotting and electron transport chain. Question on the fat solubles to be absorbed in the intestines, because it's mainly water, so B6 and B7 for sure, but it also releases methane gas, which you use for aromatherapy. There you go. That is the digestion point. The small intestines, you got to think about this. They're like 20 feet long, but the way the villi are, it just exponentially increases the surface area of it. While the large intestine's 8 feet long. You got a lot of intestines in there. Well, there it was. That was Digestion Simplified. I hope that helped. Like this video and stay tuned for more.